Dear students, greetings for the day. Today we will study about airport security. How does airport security work? Given the current state of the world, there are physical checkpoints, baggage scanners and metal detectors almost everywhere. With that in mind, it doesn't come as a surprise that at airports, some of the busiest hubs for transportation, security is getting tighter by the day. The devices and machines used for airport security purposes use science from many different fields. Airport security scanning. Keeping public places, such as airports, safe is a big job. Transportation Security Administration (TSA). Screeners at airports check passengers and personal items for dangerous items such as weapons, chemicals and liquids that are not allowed as carry-on items. They use screening equipment such as metal detectors, millimeter wave machines, backscatter X-ray and cabinet X-ray machines. These devices also detect items that may be hidden. Guidelines are in place for using the equipment in order to keep you safe. Ionizing and non-ionizing radiation scanning equipment. Metal detectors. Metal detectors use magnetic fields to help identify metal objects. Magnetic fields are produced by the flow of current through wires or electrical devices. Metal detectors create a magnetic field by using a brief pulse of electrical current. The magnetic field will be reflected back to the machine if there are any metal objects present, such as a watch or a belt buckle. The return signal is detected by the machine and a beeping noise is produced to alert the TSA agent. The metal detectors ignore very small amounts of metal, like the button on your jeans or small earrings. Some equipment uses non-ionizing radiation. Non-ionizing radiation has enough energy to move atoms in a molecule around or cause them to vibrate, but not enough to remove electrons from atoms. In airports, metal detectors and millimeter wave machines use low-energy, non-ionizing radiation to send energy across scanned surfaces. The energy that bounces back from the scanned surface will show the objects that are present, or it can generate an image that TSA agents can use to show items that may need more investigation. Millimeter wave machines. Millimeter wave machines use non-ionizing radio frequency waves to detect threats. The machine bounces the waves off the body and back to the machine. Millimeter wave scanners emit far less energy than a cell phone. Millimeter wave machines are important pieces of airport security equipment because they can show hidden threats such as guns and knives. If there are no weapons or other potential threats when someone is scanned, the screen turns green and shows an OK. If an object is detected, it will appear on the screen along with a generic body outline to show the location. Not everything that shows up in the scan is an actual object or threat, so TSA will perform a pat-down to confirm. Screening image. Some screening equipment uses ionizing radiation. Ionizing radiation has so much energy it can knock electrons out of atoms, a process known as ionization. Airports use ionizing radiation to scan passengers and luggage. Depending on the type of machine, ionizing radiation is used to identify objects that may be hidden by passengers and to create images of what is in luggage. Backscatter passenger scanners. Backscatter passenger scanners are used to detect threats such as weapons or explosives that a person could be carrying under their clothing. Backscatter machines use very low energy X-rays that are reflected back to the machine itself. Generally, the amount of radiation received from a backscatter machine equals the amount of cosmic radiation received during 2 minutes of flight, and the risk of health effects is very, very low. In the case of cabinet X-ray systems used to screen luggage and carry-on items, the thick walls of the enclosed cabinet and lead curtains at the entry and exit points of the cabinets keep radiation from escaping. The machines must meet strict standards about how much radiation can escape the cabinet. The machines must also have locks, warning lights and warning labels to keep you safe. Metal detection using electromagnetism. These are used in airports as one of the first and very basic levels of a security check, mainly to find weapons like daggers, guns, knives, etc., all of which are made of metal. They are also used in places like malls and theaters. A metal detector consists of an AC current generator and a coil. The alternating current that is produced induces a varying magnetic field in the coil. If a conducting metallic object is nearby, eddy currents are produced in the object due to the varying magnetic field. Those eddy currents then produce a magnetic field of their own. Thus, the net magnetic field suddenly changes, a change that is detected by a device called a magnetometer. The magnetometer then sets off the alarm, so after a complicated back and forth between the electric and magnetic fields, the metal object is successfully detected. Metal screening devices may be handheld, or walk through in nature. People with pacemakers, which have metallic contents, are therefore not supposed to pass through these metal screening devices. Baggage scanner. Luggage scanners use this technology. Once the luggage is inside, one side of the scanner releases X-rays. These X-rays pass through the bag and some of the energy of the X-rays is absorbed by the various objects in the bag, whereas the empty spaces do not block the X-rays and the waves go through without any change in intensity. These waves then hit the first plate-like detector. Before hitting the second detector, the material between the two detectors blocks the low-energy waves, so that only the high-energy waves hit the second plate. The outputs of these plates are compared, which helps us know the materials of the various objects inside the bag. Working of a baggage scanner, an image is then digitally constructed, describing not only the shapes, but also the material of objects inside the bags by representing them with different colors. Denser materials like metal or glass are represented by darker colors, while food and cloth etc. are represented by lighter colors. Machines used to detect explosives and illegal drugs. For the detection of explosives, a technology known as ion mobility spectrometry is used. In this method, the particles of the sample in its gaseous phase are ionized and their ion mobility is measured. Ion mobility is a ratio of the ion's drift velocity to the electric field due to the ionic charge. Machines used to detect explosives and illegal drugs. The method that uses the measurement of X-ray intensity after transmission through a sample can also be used to detect illegal drugs and explosives. In this case, there is a database of all acceptable colors, and if the output does not match any of these colors, the authorities are alerted. Machines used to detect explosives and illegal drugs. Apart from using machines, dogs trained to detect certain scents are also used. The most recent and exciting endeavor in security is the training of honeybees. They can be used in conjunction with advanced video computer software, and while this hasn't been executed yet, the idea alone is truly fascinating.